we are going to construct the FA for the language which has the set of string x, which is taken from this 0 1 clean star, such that x ends with 1 0. So you have seen that once you go for the finite automaton, it means we are going to define the set of transition. So we need to define the set of transitions in the FA. And how we can define the transitions? On behalf of the given language, we need to see some strings, and we see the kind of strings in the language and what kind of properties are there in the strings of the language. Here you can see that every strings of this language, or you can say every sentence of this language, ends with 1 0. So this is the only requirement. We need to construct the FA that remembers that whether the string ends with 1 0 or not. So this is the requirement. Corresponding regular expression you can say like this. We have 0 plus 1 clean star and ends with 1 0. So this is the regular expression for this case. Okay. So how we can construct? So for constructing an FA, we have seen that we need to have the set of states, and out of these states, one must be the initial state, and we have to designate some state as the final state. So here we need to start from the initial state. So whenever you go for, let us see, we have the initial state here. You can name the initial state in your convenience. Say, I'm saying that Q0. This is the initial state of your machine. Now, once you are in the initial state Q0, then you have two situations. You are getting either 0 and say you are going for the Q1, or you are getting 1 and we say that you are going to the state Q2. Whenever you are in the Q1, you can have the further two situations. You can have the 0 and you are going for the state Q3, for example this, and you have 1 and you are going to the state, say, Q4. This is this. From the Q2 also we have this situation. Either you can have 0 and you are going to, say, Q5, and you may have 1 here, you are going to the state Q6. See, this is. Now, question is that can we go further here? So here, what we need actually, if you construct like this, then we need to remember the last two symbol of this language. Last two symbol is 1 0. And once you have 1 0, this is the valid string. So smallest string of this language is having the only 1 0. So this is the smallest one. So you have to remember the length 2. So once you are starting from the Q0, you have the 1 here. Then say, if you follow this path, then here you have the 1, and then you are getting 0 here. So if you are moving from 1 and 0, then if your automata ends in this state, we say that yes, 1 and 0 you have received. So we will designate this state as the final state, and we make the double circle for denoting the final state. So Q5 is the final state. Why this is the final state? Because we need, your automata need to go in, starting from the initial state, your FA must go to the final state Q5, and once it goes to the Q5, then we are ensuring that the last two symbol is 1 0. So you are going to start from the Q0, and here you have the, for the input 1 you are going to the state Q2, and from Q2 for the input 0 you are going to Q5. So if you are given 1 0 from the state Q0, then for 1 you are going to Q2, and from Q2 If you are getting 0, you are going to the Q5. And say somebody has given you only the string, say 10. So this is the valid string. So for getting this valid string, your FA must go to the final state. So actually what we need, we need that machine should start from the initial state. This is the initial state. And if the string is valid, if the string is in the language or sentence is in the language, then machine must go to the final state on taking the input sentence. So here the input sentence, or you can say input string is 10, and on getting 10, one by one, if you are at the state Q0, you have the symbol 1, you are reading from left to right. Then you are going to Q2, and from Q2 you have 0, and so you are moving to the Q5. So 10, and your string exhaust. Once your sentence means there is no further characters, means your string exhaust, and your machine is ending at the state Q5. And since Q5 you have designated as the final state, so this is the valid string. So what we need to learn here only, we need to see in every sentence of this language, it must end with 10. So say, if you have the situation like you are starting from the Q0, if you have Q0, you are getting 0 here, you are going to the Q1. When you go for the Q3, you have double 0 now. And if you have further 0, then last two symbol, actually we are going to remember last two symbol. So if you have further 0, then last two symbol is, I have told you at the beginning that once you have the transition function in the FA, you have this set of Q, and you have the set of input, and your machine goes to any one of the state. So from every state of your machine, for every symbol, you have to define the transitions. And your machine must explicitly mention that in which state your machine is going. So from Q0, if you start from the Q0, you have mentioned the transition for 0 and 1, because alphabet contains only 0 and 1. So if you are at the Q0, you have seen the transition for both the input. Now if you are at Q1, you have seen that if 0 is there, you are going for the Q3. If 1 is, you are going for the Q4. Now you have to give the transitions for these states. So whenever you are at the Q3, you have to see that if you are at the Q3 and you are getting 0. So once you are getting 0 here, it means simply you can mean that you are at the Q5, you are remembering last two symbol as 10. Here, once you are at the Q3, you are remembering last two symbol is 00. So when you receive further 0, then last two symbol is again 00. So your machine should remain in the same state for the 0. If you are at the Q3 and you are getting 1, so last two symbol becomes 0, 1, because earlier you have 0 and then you are getting 1, so it becomes 0, 1. And 0, 1, you are going to remember at the state Q4, 0, 1. So for the 1, actually you need to come at this place. Now you have given the transition for 0 and 1 at the Q3. You need to give the transition for 0 and 1 at Q4. So once you are at the Q4, the last two symbol is what? 0, 1. And when you receive further 0, if you are receiving 0 at the Q4, then last two symbol becomes 1, 0. And 1, 0 you are remembering at the Q5. So you have to come for the 0 at here. So if you are at the Q4, last symbol here, Q0 and 1, last two symbol is 0, 1. And once you receive 0 at the Q4, then the last two symbol becomes 1, 0, and hence you have to come to the Q5 because you are remembering the last two symbol 1, 0 at the state Q5. When you are at Q4 and your machine is receiving the input 1, so last two symbol becomes 1, 1. So once last two symbols becomes 1, 1, then where you are going to remember? In the state Q6. So from here, actually, you need to come to state Q6 for the case of the 1. So you have seen the transition for 0 and 1 at the state Q4. You can also see the transition for 0 and 1 at the state Q5. Whenever you are at Q5, you have the last two symbol is 1, 0. If you receive 0 here, then last two symbol becomes 0, 0. And you are remembering the 0, 0 at the state Q3. Once you have the last two symbol 0, 0, machine will be at the Q3. So you have, you have the transition. If you are at the Q5, you are getting 0. So you are going to this place from 0. Now if you are at Q5 and you have the 1, so last two symbol becomes 0, 1. So 0, 1 you are going to remember at the Q4. So here you can say from Q5, if you are getting 1, you are going to the state Q4. So you have seen the transition for 0, 1 at the Q5. Now you have to give the transition for 0 and 1 at Q6. So if you have 1, the last two symbol again becomes 1, 1. So Q6 is going to remembering the last symbol as 1, 1. If you are at Q6 and you are getting 0, then last two symbol becomes 1, 0. So you have to come to the state Q5 for the case of the 0. Now see, there is no more state remains to give the transitions, and hence you can say this is an FA for the language. And you can verify for any input. If you are given the input, say for example 0, 0, 1, 0, 1, 0, 1, 1, 0. If you have the input this, if you are supplying this input, you want to verify whether this is valid string or not. Yes, this is valid string because last symbol is 1, 0. If this is the valid string, then your machine must end with the state Q5, because at the Q5, once machine is end up at the Q5, then you come to know that last two symbol is 1, 0. So how machine can move Q5? You see here. For getting 0, at the your machine starts from the initial state Q0. For getting 0, you go to the state Q1. You are at the state Q1, and you have the 0. From you are at the state Q1 and you have the 0, so you are going to move to the state Q3. So once you are at the Q3, you have to read 1. Whenever you have the 1, you are going to the state Q4. So once you have the state Q4, you are going to read the Q0. So you are at the state Q4 and you are reading 0. So you are coming to the Q5. See, for reading up to here, the last two symbol is what? 1, 0. And that's why you have come to the Q5. Now you have further input. So you are at the Q5 and you have the 1. You are at Q5 and you have the 1. So you are going to the state Q4. So this is the state Q4. Whenever you are at Q4, you have 0 here. So 0, again the last two symbol becomes 1, 0. So machine should come again to the Q5. Now you are at the Q5 and you have the 1. This is 1. So when you have the 1, you are at the Q5, machine goes to the Q4. You are at the Q4, and once you are at Q4 receiving further 1, so you are at the Q4 receiving 1, you are at the Q6. So you are at the state Q6. Whenever you are at the state Q6 and your input is 0, so for 0 from the Q6 you are reaching to the Q5. And there is input exhaust. There is no more input. So once input exhaust and your machine is ending at the state Q5, and hence we can say that this is the valid string in the sentence. So this is the way transitions occur. Okay. So if you want to construct the finite automaton, then you have to see that what you need to remember. And For that, actually, according to the sentence of the language, you have to ensure that your machine must end up with such kind of sentences. So just like here, we have the 10 at the last, and we have to ensure that every sentence that ends with 10 must be machine must go to the state Q5, because Q5 is the final state. And hence, if your machine is at final state once the input exhaust, then we will say that okay, this is the string which is accepted by the machine. If say if you are going to supply the input 001, if somebody gives you, if you are given 001, then how you can, if you have to begin with 0, q0 here, and for this 0 you are moving q1, for second 0 you are going to the q3. Once you are at q3, you have 1, and you are coming to the q4. And once q4 and there is no further input, and your machine is going to end up with the q4. Since q4 is not a final state, so this is not the valid string in the sentence. Means x is not a string in the language. So once you have constructed the automaton, you can say that string is accepted if and only if your machine has to start from the initial state, and for such a string, your machine must end up with the final state. Once your machine ends in any other state other than the final state, then we can say that this is not in the language. And if this is the finite automaton for the language, then it must accept every possible strings of the language and no other strings. So you can verify here, for every string that ends with 10, your automaton is going to end with Q5. And Q5 we have designated as the final state, and hence we say that this finite automaton is accepting the language L, where every string of this language ends with 10. So this is one way to construct the finite automaton for this language. Okay. So you need to remember how much length. You need to remember the last two symbols, and for remembering the last two symbols, you can also say that we can write, there is no problem, L2, where 2 denotes last two symbol is 10, means you need to remember the last two symbols. So here, how many states are there for the L2? If you have the L2, it means you need to remember the last two symbol, then you need 7 state. Okay, so you have the 7 state, 1, 2, 3, and 4, 5, 6, and 7. So in every layer you say this is 1, and here you have the 2, and here you have the 4. If somebody asks you to construct the FA for the language, say L3, you have the L3, where L3 is what? L3 is 0, 1, clean star. Say I'm going to remember the last 3 symbols should be 100. Similarly, here last 2 symbol is 10, and here last 3 symbol is 100. Before that, whatever be there, 0 or 1, I don't mind. But last 3 symbol must be 10. If string ends with 100, then this is the valid string. So this is we can say that your machine is going to remembering the length L3. So here, if you are supposed to construct the machine for the L3, then what you need to update here? You just go one step further, and again you can say that if you are at the state Q3, because you need to remember the length 3, so you have to go further, and you say that from the Q3, you say that you are going for the, again for 0 or 1, you have to define the transition. You are going to the state here. From Q4, you have to define the transitions for 0 and 1. Okay, for 0 and 1. and you are in some state. From Q5 also, you have to define the transition for 0 and 1, and you are in the states. From Q6, you have to mention the transition for 0 and 1, and you are going to some state for 0 or 1. And again, you have to give the transition for such state. So 0, if you are starting from the from Q0, then for 1 0 you are at the Q1. From next 0 you are at the Q3. For next 0 you are at this state. So last three symbols becomes triple zero. If you are at this state, then 0 0 and then 1. Last three symbol becomes 0 0 1. Now if you follow this path, so 0 1 and 0, this is, so 0 1 0 is the last three symbol. 0 1 1, this is the next. If you follow this path, 1 0 0, so this will become the final state now. So if you construct this, so you need to remember the string 1 0 0 1 0 0, then this is the final state. Okay, so this will be the final state, and similarly you have the other states. So what you need actually, if you are supposed to construct the one double language, if you have the language that ends in 1 0 0 and you want to construct the FA for this language, then you need further these states. So if you want to remember the last three symbol, you have in the language L3, how many states you have in the machine? So you have 4, and you have added further 8 states. So 2, 4, 6 and 8. 8 state you have further, 7 plus 8. This becomes 15. Now if somebody asks you that, you have to remember the last 4 symbol, L4. You have the language where you need to remember the last 4 symbols. Say 1, L4 can be, say that 1 0 0. You need to remember L4. We have say 1 0 1 clean star, and say 1 0 0. Last 4 symbol is 1 0 0. So what you need to do? Now you have to go one step further, and here 0 0 0 3 symbol. Now you have to, from here you can further go one step further, and for 0 1, here also for 0 1, and here also for 0 and 1, and from this state also you have to give the transition. From this state also you have to give the transition, and from this state also you have to give the transition like this. If you are here, you have to give the transition for 0 1, and from this state also you have to give the transition. So see, if you want to remember the last 4 symbol, then again you have to move one step further, and now you will have in any one of these states. If you are having these states, you are remembering the last 4 symbol. If you are at this state, then you are remembering the last 4 symbol as 0 0 and again 0 0. If you are at the last here, you are remembering the last 4 symbol as like this, 1 1 1 1, and so on. So whatever is your target one, you can designate that state as the final state. So this is important. Now the question is that once you are having the language that you need, in which you need to remember the length L4 like this, so how many states you have? You are having the 8, and now here you have further 16. You are adding the 16. So total becomes 31. So like this. So if you are going for the L5, then how many states? Here you have the 16, and you further add the state. So how many? You have the 4 here, you have the 8, now you have 16. Now in this last last step you have the 32 step. So 32 states you have to add further. So this is 31 plus 32, and this becomes how much? 63. Now see, is there some relationship? If somebody asks you that, okay, in general, if I want to learn the last n symbol, then how many states will be there in this kind of machine? So how would you know? So if you have, see the situation, if you are supposed to remembering the length 2, then you have 7 state, and you can say here, this is, you can say 2 raised power, you need to remember the last 2 symbols, then 2 raised power 2 plus 1 minus 1. You can write like this. So 2 raised power 3 minus 1 means 7. What you can say? 2 raised power 3 plus 1. Why 3? Because you want to remember the length 3. 3 plus 1 minus 1. So 2 raised power 4, 16 minus 1, 15. Similarly, 2 raised power 4 plus 1 minus 1. 2 raised power 5, 32 minus 1. This becomes the 31. And here you have, this becomes 2 raised power 5 plus 1 minus 1. 2 raised power 6. So this becomes minus 1, and this becomes the 63. So what you need to have for remembering the length, last n symbol, you have 2 raised power n plus 1, then minus 1. This much number of states you need in general for remembering the last n symbol of this language if you are going to construct the FA for such kind of language like this. So see the situation. If you are going to construct the FA where you need to remember the last n symbols, then you are going to construct like this, and you need exponential states here. N can be anything. If n is small, you can say your number of states will be finite, you can say. And once n is sufficiently large, say you might be interested for remembering the length, say 50. So 2 raised power 50 is too much. 2 raised power 100, if you want to remember the last 100 symbol, last 200 symbol, then what you need, this is exponential in nature. 2 raised power 100 is exponential, 2 raised power 200, 2 raised power 400, if you want to remember the length 400. So if you are constructing the machine like this means what? Very soon you need exponential states. If you have to remember this, even you are going to remember the last 50 symbols, this is much number of states. And if you have the exponential number of states, infinite possible states, and this is not the way you are going to construct the machine, because we have seen that in case of the finite automaton, we must have the finite number of states. The number of states must be finite. And if you are supposed to remember the sufficiently large amount of information, means you may go for the, say, you want to remember that you need 1 million, last 1 million symbol you need to remember, then this is, your FA needs exponential state. And hence, this is not the good way to construct the finite automaton for the language like this. So question is that, so is there any other way to construct the FA so that we can take less number of states as compared with this? So what is our objective? Whenever you are constructing the FA for any given language, we need to think the FA that should have the smallest number of states. So your FA must have the minimum number of states. So our whenever you are supposed to go for the FA, we need to ensure that you must have the minimum number of states. Minimum number of states as possible. This, and hence we are saying that we are interested for the smallest FA. So there are a number of ways to construct the FA for any given machine. Like you are given some problem, and if somebody asks you that, okay, can you construct the algorithm for this problem? So there are a number of possible algorithms. Everybody can construct the algorithm in their own way. But we need to select the algorithm that should take the less number of resources. Means less number of computational side time should be less. Number of memory space requirement for your algorithm should be less, and other resources needed by the algorithm should be less. So we need to prefer the program that should terminate in reasonable time with smallest possible consumption of storage. So here also, once you are going to construct the FA, so FA for any language, if somebody asks you that construct the FA for this language, then you can construct in your own way. And this is not the unique actually. So, but the language represented by an FA is unique, but for a given language, you can construct different ways. So FA can be constructed, number of FAs can be constructed for the same language. And among the available FAs, like among the available algorithms of some problems, we need to select the algorithm that should be efficient one. And here your FA is efficient if and only if it should have the smallest possible number of states. So we need to obtain the FA. Our aim is not to construct the FA. Our aim is to construct the FA that should have the minimum number of states. So minimum number of states is the requirement whenever, and then people will say that, okay, yes, this is the reasonably good FA you have constructed. So question is that how you can obtain the minimum state DFA. This is one question. We will see this topic later in the details. There we will discuss some formal algorithm, and using that algorithm, you will come to know that you can construct the DFA that should have the minimum possible state. Here, the question is that once you are constructing the, like we have constructed the FA for the language that ends in 10, okay. So for the language we have constructed which ends in 10, and you have seen that you are going to construct the FA like this, and here what is our interest? Our interest is only in 10. Before that, whatever string you have received, we are not interested on that. We are just interested in the last two symbols. And so you can say that whenever you are here for the Q0, you are going to the Q1. Means you are remembering that I have received 1, 0. Then from Q1, you are going to Q3. Means you have remembered that you have received 2, 0. And see, in case of the FA, there is no additional storage you are providing. The only way to remember is by means of the transitions. So you are in some state, on behalf of the input, you are going to transit. So once you are here, you come to know that yes, you have the last two symbol is 1, 0. And this is the way. So we are not interested in 0, 0. You can receive any 0, 0, 0, 0. I don't mind. What I am interested, when you are receiving 1, then I may be interested for getting 0, because once you have 0, then this will satisfy the condition, and hence I can go for the final state. So using this concept, some states where we don't require to remember the information, we need to merge. So later on we will see that how we can merge the states that are equivalent, so that you will find the minimum state DFA. We will see this in next classes. But for the time being, you see that how you can construct the FA for this language. So see, if you want to remember the last two symbol as 100, so you can go like this. So you have the initial state Q0, right? Now, what I mean, once you have 0 plus 1 clean star and you have the 10, this is the language we have. So here you can have any combination of 0, 0 or 1, and whenever you have 1, then you are receiving 0, then it is up to. So you are at the state Q0 and you are receiving the 0. So you don't want to remember how many zeros you have received here. So you can make a loop here. We are not interested. Okay, you give the 0. I remain in the same state because I don't want to remember, and hence I don't want to transit the state. So what you need actually, whenever you are at the Q0, I told you that in case of the FA, from every state, you have to give the transition for every possible inputs. So you are at the Q0, for the 0, you say that you remain in the same state because I don't want to remember the 0. And whenever you are getting 1, you need to transit the state. You have to transit the state because you need to remember 1. And whenever your machine is at Q1, it knows that for 1 you have come, means the last symbol you have is 1. And once last symbol is 1, and if you are receiving 0, then 10 will be there, and this will be the value. So if it is 1, and if you are receiving further 0, you have 1 and next symbol is 0, then you are going to state, say for example, Q2. And if you are in the Q2, then you know that the last two symbol becomes 10, and hence Q2 is the final state now. But this is not the finite automata here, because you have to give the transitions for Q1 also, and you have to give the transition for Q2 also. You have seen at the Q0, but now you can see at the Q1. If you are at Q1 and 0, you are going to the Q2. If you are at Q1 and somebody gives you 1, and any number of 1 you can give, so you remain in the same place. You don't want to transit here because you don't want to remember how many ones you have received. Just simply, whenever you are at state Q1, your machine knows that the last symbol is 1. That's all. So you have seen the transition for 1 and 0 at the Q1. Now, once you are at the state Q2, whenever you are at the state Q2, then you have the two situations, either 0 or 1. Whenever you have 0, then again you need to wait for the 10, means whenever means problem remains same actually. So whenever you are at the Q2, you have the 0, which should come to the state Q0. So 0. If you are at Q2 and you are receiving, machine is receiving 0, you come to the Q0. And whenever you are Q0, any number of 0 further you receive, it remains in the same place. Whenever you have 1, you are here. Whenever you have 0, you are here. If you are at the Q2 and you have the 1, then machine should come to the it should come to the state Q1. This is for the case of 1. So whenever you are at the Q2, input is 1, you should come to the Q1, and whenever you have 0, you come to the Q2. Last two symbol becomes 10, and this is the final state. And or if you are Q1, if you are for receiving the 1, remain in the same place. So you have seen the transition for 0 and 1 here. For if you are having state Q1, for 0 and 1, you have seen the transition. From the state Q0, for 0 and 1, you have seen the transition, and transition over. And then this is also the FA for accepting the language that ends in 10. Now you can compare. There are huge changes in the state. If you compare in these two FAs, then you come to know that in one FA you require 7 states, where in the second you are having only the 3 number of states, 1, 2, and 3. only having 3 number of states. And how many length? You need to remember how many symbols you need to remember? Last 2 symbols. So you are going to remember the last 2 symbols as 1, 0, and you have the 3 states only. And any input you can give that ends in 1, 0, you will come to know that this is in the language. So how would you verify? So see, if you are supplying 0, 0, 1, 0, then for this 0, for these 2 0, you are remaining the Q0. Then if you have the 1, from Q0 you are getting 1, you are going to the Q1. From Q1 you have the 0 and you are moving to the Q2. So this is, you are moving to the Q2, and hence Q2, your input exhaust, and your machine ends in the state Q2, because this is given string ends in 1, 0, and hence this is the valid string in the language. So what you have seen, for accepting the conditions, you have your you are starting from the Q0, and one by one you are going to find you are at the Q0 and you have the input 0. Where you are, this is the transition. You are remain in the Q0. So this is the transition, this state source for the Q0. If you are at the Q0 and you have the input 1, you are going to the state Q1. And this is the transition for the input 1 at the state Q0. And these are the transitions. So any strings you can give that is not in the language, like 1, 0, 0 or 1, 1, 0, 0. So whenever you have the 1, you are at the Q1. Again 1, you are remaining in the Q1. Whenever you have the 0, for this 0 you are moving to the Q2. And then you have further 0. Whenever you have the further 0, you are at the Q2, you are coming to the Q0. And your string exhaust. Once your string exhaust and your machine is ending at the Q0, and since Q0 is not a final state, we have designated. So you can say that 100 is not double 1100 is not a valid string in the language. So any string which is not in the language, your machine is ending. Your machine is going to end at the non-final state. But if your sentence ends in 1, 0, then your machine goes to the Q2. And hence this is also the FA for the same language. And in this FA, you have the 3 number of states. If somebody asks you to go for the language L3, means you need to remember the last 3 symbols as, for example, 100. Then what you need to, how many states you have? So what you need? From here, actually, you have to further go to the next state, and you are just adding the one more state, Q3. And now this will become the final state here. And once this will become the final state, and now Q2, now this Q2 is now no longer final state. Now this will become the final state. And then transition will have also you need to change. So you have the transitions will change. So if you are at the Q2 and you are getting 1, so where you go? Again you have to come to the Q1, because once you have the 1 here, then 1, then 0 you Q2, and again 0 Q3. So 1, 0 you will come to this. So you have seen the transition for 0, 1 at the Q2. If you are at the Q3, if you have 0, then again you have to start from the beginning. So for the case of the input 0, you are at the state Q0. Whenever you are at the Q3, input is 1. You have to go to the state Q1. So whenever you are at the Q3, input is 1, you are going to the state Q1. From Q1, once you are at the Q1, the last symbol is 1 here, and again if you have double zero, you will go to the final state. So this is the modification in the transition. And what question is that for learning the language, for learning, remembering the last three symbol in the language L3, how many states you need? 4. For learning the L2, you have earlier you have 3 states. For the L3, now you have the 4 states. If you want to further remember, say L4. If you are going for the L4, say you want to remember the last 4 symbol, like you want to remember this, then again you have to go one further state, and now this will be the final state. This is not the final state. So how many states you will have? 1, 2, 3, 4, 5. Just 5. So you are adding the what if in general, if you want to remember the length n, then you will have n plus 1 state. And if you want to remember the 1 million length, then you have 1 million plus 1 states in the machine. And hence, this is the reasonable FA for this language. So this machine is acceptable. We prefer this machine because this is the smallest machine we have. And for remembering the last 2 symbol, you can't have the you cannot construct the machine less than the 3 number of states for learning the last 2 symbol. If you want to remember, for remembering the last 2 symbol, you must have at least 3 states in the machine. And further minimum number of state, if you further minimize the state, it is not possible to construct the machine for the language that ends in 10 with less than 3 number of states. And hence, you can say that if you go for the language that ends in 10, you must have the 3 number of states, just like we have considered the earlier. So this is the smallest FA we have. So we have seen the FA, and you come to know now that you need to construct the FA that should have the minimum number of states. We have denoted, we are going to denote the FA by writing the symbol M, Q sigma, Q0, A delta. So you need know that you have the number of states, input symbols, initial state, set of final state, and you have to define the set of transitions. So you need to define this. And language accepted by the machine, we will denote like by writing the LM. So LM denotes the language accepted by the machine. So what is the language accepted by the machine? This is the set of string X, which is taken from the sigma star, such that your machine accepts the X, such that you can say X is accepted by the M. So this is the definition of language accepted by the machine. So when you say that X is accepted by M, X is accepted by M if and only if you are starting from the initial state. Like for this, you have to start with the initial state, and on receiving the input X, once your input exhausts, your machine ends with any one of the final state. If you have more than one final state, then your machine can end up with any one of the final state. There is no problem. So for this you can say we can define the transition function delta star here. Delta and delta star is different. Delta star we simply mean that you are in some state and you are not having the symbol, you have the string. So where you move. So delta star function can be defined like this. In case of the delta, we have the set, you are going to define the Q cross sigma. From any state, you have the input symbols, and on receiving every input symbol, you are moving to some states. So this is the definition for the transition function of the FA. Here we are going to define the delta star. So delta star takes the input as the string. It is not the symbol. And we come to know that once we are going to receive the input string, then what are the state we are going to move. So like you are giving, somebody say that you are in the state q0, and you have supply, you are going to give 10, for example. So what is the output? In the last we have seen that whenever you have the 10, we are going to end up with the state q2, and q2 was the fun state. So similarly, the output of this will be what? q2, and q2 belongs to what? Final state. How would you know this? So for knowing this, actually, you have to say that you can define recursively. And so for any state, okay, q belongs to q, for any state q belongs to q, delta star q null is q. This means if you are at any state and you are receiving the null string, you remain in the same state. Second, you should know that for any q belongs to q, okay, y belongs to any string from the sigma star, a belongs to sigma, then delta star, you are at the q, and you have y is from the sigma star, a is from the input, and means this is the string you have. So where you move, how would you come to know where your machine is going to reach? So what you need, first you need to know that on receiving the input string, you are at the state q, and on receiving the input string y, where your machine moves. So output of this is what? You are moving to any one of these state, and from any one of the, once you have some state, and from that state, if you are getting the input a, you have the a, then where you move. So how you can define this? By the transition function of the machine, delta. Delta is the transition function of the machine. So this is the way. This means if you are, somebody gives you that, okay, delta star q0 10, and what is the state where your machine move? So what you need, you are at the q0, you know that once you are at the q0, and then you have the null string, you remain in the same state. So whenever you are at the q0, and you are in the, for the input 1, if you are supplying input 1, then according to the transition of the machine, you have to go. So actually what you have, delta star here, delta star q0, and here 1 means 1 can be written like this. So you see that null a means 1. So you can use the definition for any, means first you need to, your definition says that, recursive definition says that first you need to know that on receiving the null string where you move. So this is the trivial condition. So on receiving the null string, if you are at the state q0, so you can define like this, delta star, you are at the state q0, and you have the null string, you will move somewhere else. And once you are in that state and you are getting 1, so where you will go? According to the transition of your machine, like this. So your definition says that whenever you are at the q0, your input string is null, you remain in the same state. This means the output of this is what? q0. Whenever you are at the q0 and you are receiving 1, where you will go? According to the transition of this machine. So this is the way I'm using the delta star. The delta star is the extended transition function. This is not the transition of machine. Delta star will show that on receiving the input string, what is the last state of your machine. So you can define the language accepted by the machine like this. this is the set of x which is taken from the sigma star, such that starting from the initial state of your machine q0, on receiving the input x, your machine must go to the state which is in the state A, means accepting state. Your machine must go to any one of the accepting states. So this is the definition of the language accepted by the machine. Okay. So this is the way you can say how you can define the language accepted by the machine, finite automaton M. The language accepted by M is the set of string x such that starting from the initial state, on reading the input x, your machine must go to any one of the final states. So this is the way you can define the transition functions of the machine.